and we are going to be looking at how to convert inexact to exact differential. Okay, how we can convert uh, inexact to exact differential. Okay, and the first thing we want to look into is the special integrating factor. So when you are given integrating factor, to use it to convert inexact to what? To exact. The second case is when you are not given integrating factor. Okay, then in that case, you're going to use a formula, okay, to generate your integrating factor so as to be able to convert your inexact to exact. Okay, and also want to look at homogeneous first order differential equation. Without wasting time, we want to look at one question of yesterday. Want to see the update of that question of exact differential. Then after that, we'll go to special integrating factor. Without further ado, let's go straight to the business of today differential. We want to solve it. Okay. So, and we said yesterday, when you are solving exact differential, you need to conform the given problem to the standard form. The attachment to your dx is your what? Is your m. So my m is what? My m is tan y minus 2. Okay, then my n is equal to x sec square y plus 1 over y. So let's get the partial differential of m to the other function respect to y. Okay, so if you differentiate tan x, that will give you sec square y. If you differentiate minus 2 respect to y, that will be 0. Okay, so welcome to this channel. You're welcome. You're welcome. Okay, welcome. As you are coming, please begin to click on the subscribe button so that you're able to type your comments. The partial differential of n respect to x. Okay, this will be equal to what? You have two functions there. You have x and sec squared y. So since it's respect to x, you only look for the variable x and differentiate that, while you keep the y function constant. That will give you sec squared y. The one here, 1 over y, that will be constant because you are differentiating partially respect to x. So you can see that this is equal to each other. So this is what? This is exact. This is exact. So, and once your differential equation is exact, what's the next thing to do? The next thing to do is to get the look for way to get the general solution. And once it is exact, then exists there's a function f as a function of two variables x and y, such that partial differential of f respect to x is equal to what? Is equal to n. Okay, then integrate both sides. So f will be equal to what? My n is what? My n is 10. My n is at 10 y minus 2. And then dx or del x. Then plus what? Arbitrary constants. If what you have here is dx, then you have arbitrary constant g of y. If it's dy, the arbitrary constant will be g of x. Okay, so that's what we have now, and this will be equal to, this is integral of two functions, difference of function, which will be integral of each of those functions. When you integrate tan y respect to x, this one is going to be at constant. So you're having let's open the integral. So we're having tan y is a constant. Okay, I can take it out outside the integral is a constant. You're only differentiating the x. And then minus 2, take it outside the integral, and then the what? The x plus 1, g of y. I give it the equation 1. Then differentiate this equation respect to the function you have here, respect to y. And that will be equal to what? You are differentiating partially respect to the function you have here, respect to y. So that will be what? Partial differential of f respect to y equal to, you have two functions there, x and y, and you are differentiating respect to y. So what you're going to do, you're going to keep the x constant and differentiate your tan x, tan y. And that will be what? The derivative of tan is sec square y. Okay? And this one is a constant, and when you differentiate a constant, that will be 0, and then plus what? Plus g prime of what? Of y. If you differentiate g of x, you're going to have g prime of y. Your partial differential of f respect to y is equal to n, is n. And the n value is what? Is equal to x sec square y plus g prime of y. So this one and this one we cancel. Then you have g prime of y equal to what? 1 over what? 1 over y. Then you can integrate both sides. Okay, if you integrate both sides, you're going to have g of y equal to what? Integral of 1 over y dy. And that is what? Natural logarithm of y plus c1. Okay, you're welcome, 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 welcome. As you're coming in, begin to subscribe straight away and begin to give the video a thumbs up. Give the video a thumbs up. Welcome, welcome, welcome. Give us a thumbs up. Welcome to the channel. This is a Math Sci Consult. Welcome, 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 welcome. So then the next thing to do now is we've gotten our g of y. Let's go back to your equation, which I call the asterisk, and substitute your g of y in that place. And that's so we now have f equal to x tan y minus 2x. My g of y is plus natural logarithm of y plus c1. And this f is equal to capital C. Okay, so you can combine this c and c1 together. That also gives you the c. So the final conclusion, we have this. And that's that on this particular question. Okay, that's that on this particular. That's the update in one of the questions that I solved yesterday. Okay, that's the update in one of the questions that I solved during the live section of yesterday. Okay, so let's go to today's work. We want to see special integrating factor. When you are given an integrating factor, when your exact differential is inexact, and you are given the special integrating factor to convert it to what? To exact. So let's go there. Plus n as a function of x comma y, the y equal to 0 is not exact. Okay, it is not exact. Then what we do is to multiply. Can you call this one equation 1? Give it a name. Multiply your equation 1 by this symbol, by mu, and the equation now become exact. Then this symbol is called integrating factor. Okay, so if you are told to show that this is an integrating factor, that means this differential equation is not exact, and then we need to show to us that this differential equation is not an exact differential. So the first thing to do, correspond this to the standard form. My m is what? My m is 2y. M is 2y minus 6x. Okay? And differentiate it with respect to y. If you do that, we're going to have 2. The second function is n, which is what? 3x minus 4x squared times y to the power 1. Differentiate that respect to x, and that will be 3, and that will be what? Minus 8x y to the power minus 1. Okay, you are only differentiating the x function here. X is there. Do that. Here also we have s squared here. So differentiate that, and that will be 2x times 4. That's 8x times the y there. The y to power minus 1 is a constant. So automatically, this is what? This is not equal to each other. Okay, this is inexact. This is inexact. This is inexact. Okay, so we have shown that truly is inexact. Then the next thing to do now is to use the integrating factor to multiply the given differential equation. Let's do that. Let's do that. Come here. So we're having, let me make it this way. So multiply this one by the given x times y squared, which is going to affect each of the items. So x times y squared times 2y, that will be 2xy cubed minus 6x times this x y squared, that will be 6x squared, and then y squared, close the bracket, the x, then plus. Do the same thing also for this one. This will be 1 is here, x is here, x is here. That's 3x squared, and then y squared, then minus this 4x squared times x, that will be minus 4x cubed. And then we have this one, y to the power 2 times y to the power 2 times y to the power minus 1. So that will give you, if you apply your indices, you're going to have y. So close the brackets in that place. So that's what we have. Okay. Then automatically, when you use your integral factor to multiply the given differential equation, definitely it will be exact. But let me show that to prove that it is exact. Let's do that. Our m is what? Our m is this 2 minus 6x. So this is what we have. And we differentiate that partially respect to y. If you do that, this is you only look for where you have the y function and differentiate that partially. So that will be 3 times 2, that's 6xy squared. Your x will be kept as a constant. Okay, then minus respect to this is 2 here, y to the power 2. So 2 times 6, that's 12 x squared y. The y squared will also be kept as a constant. So we've done the partial differential of m respect to y. Welcome for coming on board. Welcome. As you are coming in, begin to subscribe to the channel. Begin to subscribe to the channel. Okay. Thank you, Supreme. Thank you. I can see Z, or what's the name? Something. Thank you for coming on board. You can see energy equal. Thank you, all of you, for coming on board. Begin to subscribe straight away. Begin to subscribe straight away and begin to inform your friends to also come online. Thank you for coming on board. So let's continue. Let's continue from where we stopped. So what we're going to do now is to also the n. The n is this. So do that respect to x. Do that respect to x. So you only differentiating the x variable. So x squared is here, so times 3, that's what? That's 6x, and then y squared. You can see it here also. And then s cube is there, 4s cube. So that would what? 3 times 4, that's a minus 12, s squared. Then you keep your y constants. So if you check, automatically it is what? It is exact. That is it. So once you use your integral factor to multiply your differential equation, definitely it will be exact. Okay, so once it's exact, then we follow the procedure to get the general equation. So we now have this is exact, this one and this one are equal to each other. So this is now exact differential. Okay, so what we do now is that there's a function f such that partial differential of f respect to x is equal to what? Is equal to m, the functions of x and y. So that's what we have there. That's what we have there. So we can integrate the two sides. So if you do that, we're going to have f equal to integral of my m is this, that's a 2y minus 6x, close the brackets, and then dx, either dx or partial differential or del x. This one, okay, let's open the brackets, check what we've done so far. That, so this is my m, so let me quickly adjust that square. Okay, that's my m, okay, and then dx. Okay, so let me put it here. So f is equal to integral of 2xy cubed minus 6x squared y squared, okay, dx, and then plus g of y. Okay, so, and don't forget, you are integrating partially with respect to x. So just look for the x there and differentiate and integrate that variable there. So this is power 1, so that will be 2x squared, okay, over 2. This y will be kept as a constant. Okay, so this one and this one we cancel. Then minus, this one also do the same thing also. Integrate the s squared. That will be 6x, the power 2 plus 1, that's 3 over 3. Keep your y constant equal to what? Equal to plus g of y. And that's your what? That's your f. So welcome. You're welcome to this channel. As you're coming here, begin to subscribe straight away so that you can be partaker of discussion. Able to welcome. I can see you. Thank you for coming. Thanks for your comments. Thanks for your love. Give us a thumbs up as you're coming in. Subscribe to the channel and share the links. Okay, share the links. Energy equal. Thank you. Supreme. Thank you. I can see you. I can see yes. 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 D4. Thank you. I can see others. I can see others. Thank you. Please inform your friends also to come online. Inform your friends also to come online. Okay, let's work together. Inform your friends to come online. Welcome. Okay, so this is what we have now. Then f is equal to x squared y cubed minus 2x cubed y squared plus g of y. So call this one equation, maybe equation 1, whatever name you want to call it. That's asterisk there. So that's what we have now. Then what we now do is to what? Is to differentiate this equation, respect to y. So if you do that, we're going to have, we're differentiating partially respect to y. So we're going to have del f del y, and del del y is equal to what do you call it? Is equal to n, which is 3x squared y squared minus 4s cubed minus 4x cubed y, okay, equal to, then the right hand side begin to differentiate that with respect to y. This is y cubed. So if you do that, we're going to have 3 x squared y squared. Okay, the x squared is a constant. You won't touch it. Just the y variable. You're going to differentiate. Then here, do the same thing also. Minus. Differentiate this one with respect to y. 2 times 2. That's a 4. 4 x cubed y. 2 times 2. Okay. And 4x cubed y. That's very good. And then differentiate your g of y. And that will be g prime of y. So that's what we have there. So I think I don't need I can clean this one. Okay. So, and one thing you must know is that, and that will tell you what you are doing is correct. Okay. The moment you substitute your either the left the y or the left the x, okay. The moment you substitute it, it must be equal. It must have some similarity with the other parts. Something must cancel out. So you can see this one, all this one is there, all this one is there. So cancel out. So I only have g prime of y equal to what? Equal to 0. So it cancel out. Okay? Then integrate both sides. So g of y is equal to what? Integral of 0 to y. And then plus c1. And that's 0 plus c1. So just come back here and substitute your what? Your g of y. This one. And that's the answer to that question. So if you have this is your differential equation, okay, plus this, the y equal to 0, and this is not exact, it's not exact, then you can try the following formula to use to get your integrating factor. Your integrating factor is not given, so you have to determine the integrating factor. So you can use the formula to do that. So the first one will be what? Will be this one, partial differential of m respect to y minus partial differential of n respect to x all over n. Okay, all over n. So, and in that case now, that will be this is continuous. This is continuous. This is continuous and depends on x. And depend on x. And depend on x. So in that case now, your integral factor will be equal to what? Will be equal to e to power this one. Once we start with partial differential of m respect to y, then the next one will follow. So the function that end here is n. That will be the one that will be at the bottom. The second one, number 2. So, and don't forget, it must be, by the time you do the fraction, by the time you do the algebra, it must be functions of one variable. So if it's functions of 2 variables, then nullify. Then you have to try the second formula, which is what? Reverse the process. That will be is continuous. Is continuous and depends on y. This depends on and depends on y. Okay, so the integral factor will be the same thing, e to power the whole of the fraction. Generates your integral factor, and once you do that, then you can use it to multiply the given differential equation. And by the time you do that, by the time you multiply with the given differential equation, you need to repeat the process of exactness. Okay, do the experiment and check if it's exact. So if it's exact, then maybe once you get your integral factor and you multiply, it must be exact. And then you follow the process. Okay, so that's that and that. Let's see questions to do solve the following differential equation. This one is differential equation. Okay, we have xy dx plus 2x squared plus 3y squared minus 20 dy equal to 0. So we're just told to solve that information, but this follow the standard rules. Follow these solution. This follow these standard rules. This is dx and then plus n as a function of two variable and dy equal to 0. So in that case now my m is xy. So partial differential of m respect to, you're going to do this dx, the attachment to dx, differentiate that partially respect to the other function, dy. Okay, so look at what we have here. We have x1, so we are only differentiating partially y, keeping your x constant. So we have this. Okay, your n is what? Your n is x 2x squared plus 3y squared minus 20. Okay, so do this this n respect to other function respect to x. Okay, and that will be equal to what? 4x. This one will be 0. This one will be 0. So you can see they are not equal. So this is what? This is I mean this one is not equal to this one. So this is inexact. Okay, so if it's inexact, we're not giving integrating factor, then that means that we are going to use the formula method. We're going to experiment with the first one. I don't know which one will be applicable. We're going to experiment with the first one. If it doesn't work, if we have two variables, we check the second formula. Let's go to the first one. This one minus this over n. This is continuous and depend on x. So let's check that. It must be functions of x. Let's do the substitution. And so this will be what? X minus 4x all over. My n is what? My n is 2x squared. 2x squared plus 3y squared minus 20. So this contains two variables. So it's nullified. We cannot use it. It must be only functions of x. It must be only function of x. So we cannot use it. We're going to try the second formula. We're going to try the second formula. Okay? We'll try the second formula. I'm going to clean this one. The second one is this one, partial differential of n with respect to x minus partial differential of m respect to y over m. So do your substitution. So this is 4x minus what? Minus this one over my m. My m is what? X, y. So you're having 3x over what? Over x, y. So this one cancel. You have 3y. So you can see this one is what? Is continuous and depends on y. So you can see we have only one variable. So the moment you have two variables, you knock it out and check the other formula. So the integral factor will now become e to power what? The whole of the fraction. We have the expression for that, which is what? Which is we can take the 3 outside the integral 1 over y. And then the what? Don't forget, I didn't put something here. You have to put the y. Okay, check your formula. That's the y. And that will be equal to what? E to power. This will be natural logarithm. Integral of 1 over y is natural logarithm of y. And don't forget your 3 outside. Okay, and this will be equal to what? If you do, this will give you y to power 3. I'll explain that. I got that. I'll explain that. Okay, I don't want to clean this one because I will need it. I will need it. So one thing you must note is this. One thing you must note is this. Anytime you have, don't forget this 3 will come to the top here. So it now become e to power ln of y to power 3. Okay, the rule is this. Anytime you have e function to the power of natural logarithm of a function. Okay, automatically it's going to be what? It's going to be that function. And that's that we have applied in that place. So once we've gotten our integral factor, what we do now is to use it to multiply the initial given differential equation. Use it to multiply the differential equation given in the question. Given in the question. Okay. So use your integral factor, which is a y3, to multiply the given differential function. So that will be equal to what? That will be equal to y3 times this one, the x, then plus what? y3, y to the power 3 times 2x squared plus 3y squared minus 20 and the y equal to 0. Okay, and that will be equal to x, y4, y to the power 4. This is y to the power 3 times y to the power 1. So dx, and then plus this one, multiply that, that will be equal to 2x squared y cubed, okay, and then plus 3y squared times 3y cubed, that's 3y to the power 5, and then minus 20 y to the power 3, the y equal k. Thanks for that comment. So, and possibly I will also say, so that's that. There's some courses when you have, I don't know if you have done it before, but people that are doing this course, they don't joke with it. Okay, they don't joke with it. So, and I want to say also, if you need one-on-one, you can check my this video, check my email, and send me an email. Send me an email. Then we can book. You can book appointment with me, and I can sit down with you one-on-one. It's very simple. Okay, you can sit down with you, and we can discuss that. We can discuss that. Okay, so that's that on that case. So we've used the integral factor to multiply the given differential equation. So what you now do now, you now do the process of exactness. Okay, this one, your m is what? You correspond this to the standard equation. Your m is what is this one. This is your m. This is your m. Okay, can you differentiate that partially respect to this is dx. Okay, the attachment to your dx is your m, and you're going to differentiate that respect to the other function partially respect to y. And when you have two variables or more than two variables and you're doing partial differential, you're going to keep the other variable constants and only spot the one you are differentiating respect to. I'm differentiating respect to y. Okay, I'm differentiating respect to y. So I'm going to keep the x constant and differentiate y to the power 4. And that will be 4xy cubed. That one is done. Okay, welcome. As you are coming in, begin to give us a thumbs up. Type your questions. Type a question. I'm going to respond to it. I'm looking at it. Type of questions. Type of questions. Type of questions. And thank you for coming on board. Thank you for coming on board. Okay. This is the engineering maths. Okay. This is engineering maths. Okay. This is engineering maths. Yeah. So this is what we have now. Let's go to the n. The n is the attachment to your dy. The attachment to your dy is your n. So which is what? Which is this one plus this, and then minus 20y cubed. So you're going to differentiate the n. This is the y. You do it with respect to the other function, respect to x partially. And when you're doing partially respect to x, what you do is very simple. You just spot the x variable alone, and that will be 2 times 2, that's a 4x. The y will be kept as a constant. This one is y function, this one is a y function. You are differentiating partially respect to x. So this is a constant, this is a constant, and that's what? That's 0. Okay, so automatically, this is now exact. This is now exact. Okay, this is now exact. This is exact differential equation. I think, okay, it's good to show it. But the moment you use your integral factor to multiply the given inexact equation, automatically it will be exact. I appreciate everyone. Give us a thumbs up. Okay, so that's that on these on this. So it is exact. Then there's a function. There is a function f as a function of x and y such that partial differential of f respect to x, okay, is equal to what? Is equal to m. And that's what I'm going to use to get the general solution. Then I'm going to integrate the two sides of the equation. Move these the legs to the other side and integrate. So if you integrate the left, you're going to have f. Okay, and if you integrate partial differential of f, you're going to get f, and that will be integral of what? Integral of m. Okay, the x. You can use the x. You can use the less. No problem. And that will be equal to, and then plus the arbitrary constant. That's a g of y. That's a g of y. Let's make our m. So we now go to the new equation which you have used the integral factor to multiply. So my m is what? This is my what? This is my m. That's my m. Oh, sorry. So this is my m. This is my m. So that's the integral of x times the y to the power 4. Okay, dx plus g of y. So that's my m. Okay, so call this one equation, equation 1, give it a name, and differentiate that partially respect to this function, respect to y. I'm going to have del f del y, and del f del y is equal to what? Del f del y is equal to is n, and that is my n, which is what? Which is 2x squared y to the power 3 plus 3y to the power 5 minus 20 y cubed. That's my n equal to. Now differentiate. Okay. I think I'm jumping. Let's do something before we do that. Let's do something. I'm going to integrate the x function only. That will be what? This is power 1 plus 1. That's power 2 over 2. Y to power what? Y to power 4. Y to power 4 is just a constant. Okay. So plus g of y. So call this one equation 1. This is what? This is your f. That's your f. Okay. Then now differentiate now respect to y partially. Differentiate partially respect to y, and that will give us del f del y, which is n. And my n is what? My n is this one, 2x squared y cubed plus 3y to the power 5 minus 20 y cubed, okay, equal to, differentiate this one respect to y. I'm going to have 4, okay, times x squared over 2, then y to the power 3. I'm only differentiating y to the power 4, and the 4 will go to the front, and that's it here. The x squared and over 2 is a constant. So times this. Okay. Then, so this will now become this one. We have this equal to this one. So we have 2x squared y cubed. Okay. Then don't forget, we didn't differentiate this one. That will be what? Plus g prime of y. Okay. And I've told you that at this stage, something must cancel out. So this one and this one cancel out. So and I have g prime of y equal to what? Equal to 3y to the power 5 minus 20y cubed. Okay, then you can now integrate both sides to, okay, integrate both sides of the equation to get your g prime of, to get your g of y. So g of y will be equal to, that will be integral of 3y to the power 5 minus 20y cubed, then the what? The y. And that will be equal to what? That will be equal to, this one will be equal to what? 3. When you have integral difference of functions, it's going to be integral of each of those functions. Integral of 3y to the power 5 minus integral of 20y to the power 3. So do this one. You're only integrating y to the power 5. 3 is just a constant. So plus 1, making plus 1, making 6. Over 6. So we're having 3y to the power 6 over 6. Okay. Over 6. Then the other one, that will be minus 20 y to the power 3 plus 1, that's 4, over 4, and then plus the c1, that's a plus c1. So we're going to have half y to the power 6, 20 over 4, that's minus 5 y to the power 4 plus c1, 1 over 2 x squared y to the power 4. My g of y is what? Is half. Is half plus half y6 minus 5 y4, and then plus what? Plus c1 plus 1. And this must be equal to what? Must be equal to c, capital C. So final conclusion, your answer will now become final conclusion. Final conclusion, we have this one. Equal to C. You combine this capital C and C1 together, it will give you C. Okay, so that's C. So that's that on that particular question. Okay, that's that on that particular questions. I want to say welcome, welcome. You're just coming in. You are in the right place. Okay, you're in the right place. Click on the subscribe button. Do that now. Click on the subscribe button. Okay, let's be all together. The part of let's make this section interactive. This, what they're telling us is that make this equation exact. Once you're given the integral factor, what they are telling you is what? Make it what? Make it exact. So then, the next thing to do now is to multiply the given differential equation by the integral factor. Okay, and that will be equal to what? That will be equal to, we're going to have f, this one times x, as sk plus xy dx, and then plus what? Plus this. Okay, dy. So equal to what? Equal to 0. So that's that on that. Then, so once you've used the integrating factor to multiply the differential equation, definitely the equation will be exact. Definitely, it will be exact. So that's what we are going to be. That's what we are going to base our judgment upon. Once we have the integrating factor, the differential equation will be exact. So what we do now, we know that m is what? Our m is what? Let's get the m. Our m is the attachment to the x, which is what? X cubed plus xy. So differentiate that respect to if you have the x, then you differentiate the attachment respect to the other function, the y. Well, that will be partial differentiation. That will be there y. Okay. So equal to. In this case now, what we are going to do here, s cubed, That will be constant. That one is gone. Xy, differentiate the y in that place. That will be x. So that's what we have in that case. Okay. Let's the n also. Let's get the n. My n is this function, and that's my n. Let's also do that. Do the partial differential of that equation. The attachment to your dy is your n, and differentiate that respect to the other function partially. That's dx, del x. Okay, and this one is going to be a product through. It will be a product through. Differentiate this one. You have f of x, then plus what? Plus. Keep this one constant and differentiate f of x. That will be f prime of x. Okay, in a nutshell, this is the same thing as what? X times what? F of x. Then open and close your brackets and put differential there. Put your prime there. The thing is this: nothing happened by chance. Okay, you need to solve as many questions as possible. That is it. That is the trick. Okay, that's the trick. Solve as many questions as possible. That's it. Practice make perfection. The more you practice, the more perfect you become, and to be easy for you to have A in this course. Look for questions. Okay, look for questions. Okay, you have to spend time. What to spend time with, develop. It grows. It's what you spend time on. It improve. You improve. Okay, if you don't spend time on particular things, it will be difficult to get the complete understanding on that something. Okay, and I've always say that this is not a movie. You need to take your journal. That's the bitter truth. Take your journal, take your pen, and begin to walk along with the speaker. You too can also discover that there's a mistake somewhere, and then you can make it on the comment section. Okay? Nobody's a monopoly of wisdom. Take your journal, take your pen, and begin to walk along with the speaker. It's very important. It's not movie. Okay? Thank you for that. So this is what we have. This is what we have. Welcome, 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 welcome. You're just coming in. You are in the right place. You are in the right place. Begin to subscribe so that you can type your comments. Give the video a thumbs up. Give us a thumbs up. It's very important so that it will make the algorithm to push the video to larger audience. Okay, to make the algorithm, the YouTube algorithm, to push this video to larger audience. Okay, so please begin to do something. You can type your comments, say something. I like the way you are doing. You are doing a good job. Oh, excellent. Begin to make a constructive comment. You want to cancel differential, then you have to integrate both sides of the equation, and that will be equal to what? This will be equal to if you integrate x, that will be x squared over 2 is having power 1, so plus 1 over 2. This one, respect to this. Okay, if you integrate this one, the differential will cancel. So we have this over 2 plus the constant of the integration equal to what? Equal to this. Equal to this. So what we're going to do now is to make this one the subjects. Okay, to make it the subjects of the equation. Okay, and that's what we are looking. We are looking for. That's what we're looking for. Okay, so remove this function here from here, and that will be what? You divide both sides by x. So that will be, if you divide that in this place, that will be x over 2 plus c over x. Okay, s squared over 2 divided by x. Okay, so that's correct. That's correct. Then plus what? Equal to f of x. Okay, and that is the end of that solution. That's the end of that solution. welcome to the channel. If you're just coming in, please um, subscribe to the channel. Subscribe to the channel. Subscribe to the channel. Subscribe to the channel. Actually, this one over X does no meaning because it's a constant. Okay, I can leave it there. So I think if you leave it this way, x over 2 plus c plus c. Okay, equal to what? Equal to f of x. Equal to f of x. So drop your comment. Let's see what you feel. No, let's see what you feel in that case. I think I think it's okay. It's okay. Okay, but say something in the comment section. Okay, say something in the comment section. I want to say something on the comment section. Okay, so that's that on these converting inexact to exact. Okay, the next one I want to see now is homogeneous first order differential equation. That's the way we're going to now. But let me just salute us for coming online at this time. Okay, thank you for coming on board. Thank you for coming on board. Please share the links of this video. Let it go viral. Share the links of this video across your social media platform. Share the links of this video across your social media platform. Okay, tell your friends to do likewise. Subscribe down. Okay, I want the number to. I want people online to. I want a large number. Okay, let's support this channel. Okay, tell your friends. Okay, let's go on to the homogeneous first order differential equation. Homogeneous first order under that substitutions and transformation. Okay, so how do we solve homogeneous differential equation? How do we solve homogeneous differential equation? Step 1 on how to solve homogeneous differential equation. Change the equation. Change the equation. Change the equation. Change your differential equation to this form. To form the differential equation, change it to form this. ddx equals what? F as a function of y over x, or f as a function of what? X over y. Okay, so that's what you do. That's the first thing. The first order means the highest differential there is 1. So change the equation to form this. Then after that, then the next thing to do now is to make substitution for y over x. Make a substitution. Let y be equal to vx. Let y be equal to vx, which is the same thing as what? Or which is the same thing as v equal to what? Y over x. So then now differentiate this one respect to x. So that will be y dx equal to. Can you differentiate the x function? Keep the v constants. So you have v plus is a product rule. So keep your x constant and differentiate the v. So that will be v dx. Okay. Exactly now. Then the third case, step 3, is to go back to your we say change the equation to this form. Go back to this the first step and make your substitution there. Anyway, you see your dy dx, put this one there, which is what? V plus x dv dx. Okay, equal to anyway you see y over x, plug in that will be f of what? F of v. Okay, and then the process continue. Something we cancel out. Then you now use separation techniques. Okay, you separate the variable Okay, use the separation techniques, and then do the after that do the process for separation techniques. So let's see questions on these aspects. So that's how to solve homogeneous first order differential equations. The thing, thank you. Please subscribe to the channel if you are yet to do that. Just coming in, subscribe to the channel, give the video a thumbs up, give us a thumbs up, show us love, okay? Begin to type your comments, okay? Don't stop there. Make it a multiplier effect. Tell your friends. Share the links of this video across your social media platform. Thank you for doing that. Okay, so this is what we have now. We have to solve the YDX equal to this. Solve the YDX equal to this. So the first thing to do when you see a question like this, do the little algebra. Do your algebra solution. So the y, the x is equal to. The meaning of this fraction is this one over this one. That's 1 plus this one over this one. That will be what? This one over this. So this one and this one cancel. So we have what? Y over what? Over x. And finally, this one over this one, which is y over x squared. Okay, that's step 1. Step 2, make a substitution. Let what? Let y be equal to vx, or v equal to what? Y over x. You're going to use the 2. So differentiate this one respect to x. So we're going to have dy dx equal to. This is a product rule. Differentiate this the second one. That's 1. Keep your v constant. Now keep your x constant and differentiate the v respect to x. Okay, equal to what? Make substitution for the right side, 1 plus y over x. That's what? That's v plus what? Plus v squared. As I said in the introduction, something we cancel. V we cancel out. V we cancel out. Don't forget your divide dx stays is okay. Before I do that, before I do that, don't let me be too fast. Before I do that, okay. This, my if you differentiate this, we have this. Okay, now and then, we differentiate this, we have this. Okay, we have that. So what we're going to do now is to go to this equation and make substitution for dy dx, and that will be what? That will be v plus x dv dx equal to. Then make substitution for the right hand side, which is 1 plus v plus v squared. Okay, so this v and this v we cancel out, and after that you separate the variable. You use separation techniques, okay, of differential equation to solve it. Okay, use separation techniques to solve it. So we're going to have now, we're going to have this one, x the v dx equal to 1 plus b squared. 1 plus b squared. Okay, 1 plus b squared. So what we're going to do now, we're going to remove this one from here. You can cross multiply, so that will be equal to what? X dv equal to what? 1 plus b squared dx. So remove this 1 plus b squared from here. So divide both sides by 1 plus b squared, and that will be equal to what? That will be equal to 1 over 1 plus b squared, and then remove this x from here. Divide both sides also by x. So you have what? 1 over x dx, and then integrate both sides. Okay, so I want to say, if you are doing this course and you know somebody that is doing it, okay, please give me an email. We can have one-on-one discussion. Okay, you can join my online class for engineering maths, or any of your courses. Okay, just let's talk together. We can book your place for whatever course you are doing, or you have an assignment. Send me an email. We can discuss that. So let's go on. That will be Act 10 B equal to what? This one is going to be, if you integrate one over x, that will be ln x. Okay, plus what? Plus c. Okay, then you can substitute, because v was not part of the question. We turn that back. V is what? I think we said uh, y is bx. So v is equal to y over x. Is y over x equal to what? And then x plus what? Plus c. You can stop here, and you can also do efficiency is allowed. You can continue if you want. You can continue because you want to make y as the subject. So if you want to do that, you're going to take the arctan of both sides of the equation, and that will be equal to what? Y over x equal to what? Arctan of this function, natural logarithm of x plus c. Okay, you take the arctan of both sides. What am I saying? You take the tan of both sides. For you to negate arctan, okay, you take the the tangent of both sides. To negate arctan, you take tangent of both sides of the equation. Take tan of this one, it's going to give you the function inside, and this will be what? This will be tan of this function. And the next thing to do now is to make y the subject, and that will be x tan tan the function. So that's that on this question. Let's see one more questions. Let's go to the advertisement segments. Welcome, 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 welcome. Thank you for staying by. Thank you for staying by. Okay, you can just type your comments. You're here to subscribe. Do it right now. Do it right now. We're here to subscribe. Subscribe to the channel. If you are returning viewers, please give the video a thumbs up. Type your comments and share the links of this video across your social media platform. Thank you for doing that. Thank you for doing that. So let's see the second question. Let's see the second question. We're going to, don't forget what we said in the first, in the intro, is to get the first differential. Make your first differential the subjects. So we have the y here. So I'm going to divide both sides by 1 the x. So I'm going to have xy dy dx equal to what? Equal to this one. Okay, so that's the first thing to do. You want to make the y, the x, the subjects. So then remove this one from here so that you can have your dy dx at one side. So your dy dx is equal to what? Is equal to s squared e to power minus y over x plus y squared over xy. So we've achieved the step 1. So can we do the algebra of this? So if you do the algebra of this implies this one over what? Over xy, and then plus y squared over xy. So that's the algebra. Okay? That's the algebra. That's the algebra of that. Okay? Thank you for coming online. Okay? So thank you, thank you, thank you. So that's what we have now. Um, then the next thing to do now is to this one we cancel. We have 1 here, so which is x over y. E what? E to power minus y over x. This one also, 1 we cancel here. This one we cancel, so we have 1 on top there. That's y over what? Over x. So what we need to do here is just to do, this y over x, this x over y. We just need to do the little algebra, and that will be 1 over y over x. I've not changed anything. It's just algebra. If you reciprocate it, you see the same thing. It's going to give you. Reciprocate it. Reciprocate and flip the fraction upside down. If you do that, you're going to get the original expression. So that's what we have in this case. Then the next thing to do now is to bring in your substitution. So bring in your substitution. Okay. So bring in your substitution. Okay. So the moment you are here now, this is now homogeneous. I didn't even mention that. This is homogeneous. This is homogeneous. Okay, let's make the substitution. Use your y is equal to dx. So v is equal to y over x. Can we differentiate this one? Let's differentiate this one respect to x. So dy dx is equal to what? Is equal to x is equal to v plus x dv dx. I think I've explained this. Okay, so then you now come back to this place and make your substitution. Come back to this place and make your homogeneous first order homogeneous first order differential equation with substitution in that place. Okay, so you're going to have now the y dx is what? X1, that's a v, that's v plus x dv dx. Okay, equal to 1 over v, 1 over v e minus v, and then plus what? Plus v. So now you make your substitutions, this and this we cancel. This and this we cancel. Then we have this one, x dv dx. X dv dx. What I would do, my mind is telling me that I think we should end this and make it fresh tomorrow. Okay. And probably I'll make sure that I come much earlier, by 5 p.m. tomorrow. In 5, I will update that 5 p.m. tomorrow, the Eastern time. Come on board, and then we'll solve a lot of questions. So after this one, let's put a full stop to that, and then we'll continue tomorrow. Okay. So we have this. This one will be equal to what? Let's do the algebra of this one. This will be times 1 over EV. Okay. That's what we have. So we now have x dv times v ev cross multiply, and then remove this one from here as a dx. Okay, and also remove this x from here. So I'm having v e to power v equal to 1 over x dx, and then integrate both sides of the equation. Integrate both sides of the equation. So I'm going to use this is a product of 2 items. I'm going to use integration by parts. Okay, I'm going to use integration by parts. So I want to say we're just coming in. You're welcome. This is engineering maths. This engineering maths. Welcome. This engineering maths. Okay, subscribe to the channel. type your comments, give the video a thumbs up, show the video a love, share the links across your social media platform. For the returning viewers, you need to type your comments, share the links of this video, and type your comments. So that's what we have now. Let's use the integration by parts. This will be uh, integration by parts. When you have two products, okay, and you want to integrate, then you use integration by parts. So let u be equal to u be v. So the u is equal to what? The v. Then the v is equal to what? The second function, that's v. Okay. The v. So integrate both sides, but to avoid the tautology, the v also have v here. I'm going to change it to what? To the w. Okay. So integrate both sides. That'll be w equal to what? Integral of this one. That'll be what? That'll be ev. So that's what we have in that place. That's what we have in that place. So for the formula for integration by parts is uv minus integral of v du. So that's what I'm going to use for that. So this is my uv. This is my ub. Okay, that's my ub. That's my ub. That's my uv. So that would be what? That would be v e to power v, and then minus my v is a w. That's what integral e to power v. Then the u, my du is what? Is the v. Okay. So that's equal to if you integrate this one, 1 over x, integral of 1 over x, that's a natural logarithm of x. Okay, plus what? Plus c. So that will be equal to v. That will be equal to this minus. We integrate e function to give you e function. That's equal to what? Natural logarithm of x plus c. Okay. So that's that on this aspect. If you see anything that is not clear, put in the comment section. If you see anything fishing also, then just let us know on the comment section. I want to say thank you for staying by. Okay, I appreciate your commitment.